Last year, a UNMC study on a popular herbicide revealed counties with more usage also had higher rates of breast and uterine cancer.
UNL researchers are now showing exactly how that herbicide gets into our water supply.
Channel 8's Jessica Blum joins us now with more on this. Jessica?
The common herbicide is called atrazine, and it is prevalent here in Nebraska's agriculture. The UNMC study looked into 33 counties, including Lancaster, and not only was it dangerous to humans, but also wildlife too. Researchers have detected the herbicide atrazine in various bodies of the water here in Nebraska, including rivers and our source of drinking water. Atrazine is used because one of its biggest jobs is to control weeds while maximizing yields of corn. But in doing so, it has also been found to harm wildlife and humans by curbing local plant diversity and disturbing hormone production. Professor Lee at UNL says 90% of rural Nebraska areas are using groundwater as their main source of drinking water.
Atrazine is already a concern. Yeah, so people like scientists in environmental engineering and in agriculture, people started to really care about it. EPA, Environmental Protection Agency, already set a maximum concentration level for atrazine, which is 3 milligrams per liter. So it is already a concern.
This is where UNL finds interest in predicting the future climate changes that could impact the soil's ability to absorb or filter some of the herbicide before it reaches the groundwater. Faster erosion rates of the soil due to heavy precipitation can lead to higher accumulations of atrazine in the water.
Those rates are really matters about are really controlling how herbicides can migrating and accumulating in the subsurface. So maybe we should think about some technologies or also methods to control those rates, then which can control the accumulation and the leaching to the groundwater.
After running thousands of simulations, they found pockets of high atrazine concentrations have the potential to move to our groundwater table, depending on future precipitation. Soils with little bacteria or little organic matter won't be able to absorb as much of the herbicide.
And in those areas, climate variability will have huge impact. When you have the higher precipitation, more rainfall, it will essentially push it down much quicker.
The team will be working to better model various parts of the atmosphere and the climate of the future, in which heavy rain trends could push the herbicides farther, faster, affecting more of the groundwater. Their next step will be to find out how atrazine breaks down and how to speed up that process. The future of this work will look into various types of the soils and studying that rate that atrazine is going through the subsurface layer and into the groundwater.
All right, Jessica, thank you for that report tonight. The Lincoln